Right, in this section, we are going to look at another representation of Z called the modulus argument form of a complex number. Now consider the following diagram representing the complex number. Right, let's do this diagram again. We have the y-axis as the imaginary part again and the x-axis as our real part with Z somewhere in this first quadrant. So remember, this is then r, which is the distance from Z to the origin. And then we have theta, which is the angle from the positive x-axis to this line. And we can complete the triangle. Right, so you are familiar with this by now. Now from trigonometry, we know that cos theta is equal to x over r. And solving for x from this, we get that x is then equal to r cos theta. In the same way, we know that sine theta is y over r. Solving for y from this, we get y is equal to r sine theta. So let's plug this then into the z that we already have. Then we get that z is equal to, so x now becomes r cos theta. We have the I, I'm going to put it in front, and then y is r sine theta, right? And just to rearrange and simplify this a bit, I can take the r out as a common factor, and I have cos theta plus I sine theta. So from that we have that z equal to r cos theta plus I sine theta is called the modulus argument form or the polar form of the complex number z. So it's still the same number, it is just represented in a different form. And just take note that some textbooks generally define z, which is equal to r cos theta in this form as r cis theta. Right, so whenever you see r cis theta, it is just a shorthand for r cos theta plus I sin theta. So let's have a look at an example. The question is, write z equal to 2 cos 60 plus I sin 60 in the rectangular form of z equal to a plus bi. So going from the polar form into the rectangular form, in this case, all you need to do is to simplify. So we have z equal to 2 of cos 60 degrees plus I sine 60 degrees, right? Now, from special angles, we know that cos of 60 is a half and sine of 60 is square root 3 over 2. Multiplying the 2 into the bracket, we get it's finally 1 plus square root 3i. And now it is in the required form. Right, going to the other way around is a bit of a longer process. The question says write z 2 plus 6i in modulus argument or polar form. So again, when we have it in this form, let's draw it and see what we have. So on the x-axis we have 2 and on the y-axis we have a 6. not drawn to scale, just to get an idea of what we work with. So these are, so this distance here is 6. We have a 90-degree angle, 2 here, and then theta as the angle there. And this is then the point of Z. So what do we need to write it in the modulus argument form? We need to find theta and r. So r is simple. R is the square root of x squared plus y squared, which in this case is equal to then 2 squared plus 6 squared, which simplifies to the square root of 40, and that will be 2 square root 10. So that is the value of r. Now we need to find theta. In order to do that, we can choose any ratio now. We already have the value of r, which is 2 square root 10. So because we have all 3 sides of the triangle, you can choose any one of the 3 ratios. I'm going to choose cos, and I know cos is x over r, so it's 2 over 2 square root 10. And from this, I get theta equal to 71,57 degrees. So now, putting this all together into the modulus argument form, where we know that z is represented by r cos theta plus I sine theta, we plug everything in there, where r is 2 square root 10 and theta is 71,57 degrees plus I sine of 71,57 degrees. And there you go.